أعزائي الطلبة، السلام عليكم ورحمة الله وبركاته. أهلا بكم في درس جديد من دروس الجيومتري. Similarity of Triangles Part 3. Theorem 1. If the side lengths of two triangles are in proportion, then the two triangles are similar. What does that mean? If we have two triangles A, B, C and D, F, E, their sides are in proportional. That is the given, and we write it in two triangles ABC, 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 and DEF. Their sides are in proportional. It means AB over DE equals BC over EF equals CA over FD. The corresponding sides are proportional. AB over DE equals the length of BC over EF equals the length of CA over FD. That is a given. So we deduce that triangle ABC is similar to triangle DEF, and this is the required to prove too. So if the side lengths of two triangles are in proportion, then the two triangles are similar. So the required is to prove that the two triangles are similar. If we can prove that the two triangles DEF and AXY are congruent, and we have the triangle AXY and the ABC are similar already because XY parallel to BC, then we can say that the triangle DEF is similar to triangle ABC. So the first step is to prove that triangle DEF is congruent to triangle AXY, and this is the first step. To prove that, we take X belongs to AB. We take the point X here belong to line segment AB such that AX equals DE. Don't forget that AX equals DE. And we draw XY is parallel to BC. We draw XY parallel to BC and intersects AC at Y. So XY intersects AC at Y. And since XY is parallel to BC, XY is parallel to BC, then we can say that triangle ABC is similar to triangle AXY, and we have to write it on the same order. Triangle ABC is similar to triangle AXY. This is from corollary 1. Since the two triangles are similar, then the corresponding sides are proportional. Again, since the two triangles are similar, then the corresponding sides are proportional. What does that mean? That means AB over AX equals BC over XY equals AC over AY, and we write it. Okay, this is the first thing we deduce from the similarity of these two triangles, triangle AXY and the ABC. But AX equals DE. It's from construction. We did already. AX equals DE. Then we can substitute AX by DE. And we write it AB over ED. So instead of AX we write DE because they are equal. AX equals DE. So AB over DE equals BC over XY equals CA over YA. Again, AB over DE equals BC over XY equals CA over YE. But we know that from the given AB over DE, here from the given AB over DE equals BC over EF equals CA over FD. The first term here are equal, so you can say that BC over XY equals BC over EF, and CA over YA equals CA over FD. The three terms here equal the three terms here because the first term are equal. So we can deduce that XY equals EF. Okay, and we will write it XY equals EF and YA equals FD. And we write it from 1 and 2. We deduce that XY equals EF, XY equals EF, and YA equals FD. But we have from construction that AX equals DE. Okay, back to the figure. Now we have XY equals EF, and YA equals FD. YA equals FD, and AX equals DE. So the two triangles AXY and DEF are both congruent. Okay, if the two triangles are congruent, then we can say that the two triangles are similar, and we write it. Then triangle AXY is congruent to triangle DEF because the three sides in the first triangle are equal to the three sides in the second triangle. Since the two triangles are congruent, then we can say that the two triangles are similar. Then triangle DEF is similar to triangle AXY. And since triangle ABC is similar to triangle AXY, from the corollary, triangle ABC is similar to triangle AXY. Again, ABC is similar to AXY. Then you can say that the triangle ABC is similar to triangle DEF because these two small triangles are similar too. Then we complete the proof. Then triangle ABC is similar to triangle DEF. Now, if we have two similar triangles, then the corresponding sides are proportional, and vice versa. If the side lengths of two triangles are in proportion, then the two triangles are similar. If you have this, you can deduce this result. And we'll take some problems to explain and to understand this theorem. In the figure opposite, B, Y, and C are collinear. B, Y, and C are collinear. It means B, Y, and C, these 3 points, are on the same straight line. Prove that triangle ABC is similar to triangle XBY. Prove that triangle ABC is similar to triangle XBY. The required number 2, ray BC bisects angle ABX. Ray BC bisects angle ABX, this angle. Of course, we will use the previous theorem to prove the first part. Solution: in the two triangles ABC and XBY, we get AB over XB equals 12 over 9, which equal 4 over 3. BC over BY equals 18 plus 6 over 18, which equal 4 over 3. And the AC over XY equals 18 over 13.5, which equal 4 over 3. Then the corresponding sides are proportional. Then you can say that triangle ABC is similar to triangle XBY. Again, how we choose these sides? Like this: BC and BY. BC and BY are both the greater side in the two triangles. Right? Right. We write BC over BY. Okay, what is the smaller sides? The small side in triangle ABC, the smaller one, is AB. It's equal 12. And the smaller side in triangle XBY is XB. It is equal 9. Okay, so the smaller side over the smaller side. The second side here, it is the greater one, BC over BY. The greater side here equals 24 over the greater side in the second triangle is 18. And we write the third one, it is the middle in a range, AC over XY, 18 over 13.5, all equal 4 over 3. So we can say that AC over XY equals BC, BC over BY equals AB over XB, all equal the same ratio, 4 over 3. Then corresponding sides are proportional, so we can deduce that triangle ABC is similar to triangle XBY, and this is the first required. Second required: since triangle ABC is similar to triangle XBY, then the corresponding angles are equal in measure. That means measure of angle ABC, here equals measure of angle XBY. Then BC is the bisector of angle ABX. These two angles are equal. Then you can say that the ray BC is the bisector of angle XBA or ABX. It is the same. And this is the required. Example: in the figure opposite this figure, AB, ray AB intersect ray CD equals E. The ray AB intersects ray CD outside here at point E, where AE over CE equals BE over DE, where again AB over AE equals BE over DE, and AC over CE over CE, again AC over CE equals BD over DE. Prove that straight line AC is parallel to straight line BD. Solution: since AE over CE equals BE over DE, it is from the given AE over CE equals BE over DE. We will use properties of proportional. We can say that AE over BE equals CE over DE. Again, AE over BE, antecedent over antecedent, equals consequent over consequent, means CE over DE. And this is number 1. And from the given 2, when we have AC over CE equals BD over DE. AC over CE equals BD over DE. Then we use the same property, antecedent over antecedent, numerator over numerator equal denominator over denominator. It is the same meaning. AC over BD equals CE over DE. It is number 2. From 1 and 2, we can get AE over BE equals CE over DE equals CA over DB. Here we have a common term, CE. The right term here is CE over DE. It is the same here, CE over DE. So these 4 terms are equal, and we rewrite it. AE over BE equals CE over DE equals CA over DB. And now look to the figure. What does that mean in the figure? Here in the figure we have AE. It is a side in triangle AEC. AE over BE. Another side in triangle EBD equals CE over DE. CE over DE. CE is the second side in triangle ACE, and DE is the second side in triangle EBD, equals CA, third side here, like a base, over DB. CA over DB. So the 3 sides in the 2 triangles are in proportion. Then according to the theorem, we can say that triangle AEC is similar to triangle BED. Again, back to the figure. Triangle AEC, where AEC, it's the big one, similar to triangle BED. And we can say the corresponding angles are equal in measure. It means the measure of angle ACE, this angle ACE, equals measure of angle BDE, and they are in corresponding position. Then we can say that DE is similar to CA, or we can write AC is parallel to BD again, and then we can say that DB is parallel to CA. Then we can write straight line AC is parallel to straight line BD, and they are corresponding with respect to the transversal CE. With respect to transversal CE, these 2 angles are in corresponding position. Then AC, straight line AC, is parallel to straight line BD. ABCD is a quadrilateral. ABCD is a quadrilateral, and E belongs to BD. The point E belongs to BD, where AB over DA, AB over DA equals CE over BC equals CE over BC, and BD over DA, BD over DA equals EB over BC equals EB, over BC. Two sides from triangle ABD and two sides from triangle BCE. The required to prove is prove that AD is parallel to BC, AD is parallel to BC, and AB is parallel to CE, and the AB. The idea is to prove that triangle ABD is similar to triangle EBC. If these two triangles are similar, you can say that this triangle equal this angle. Angle EBC equal angle ADB in measure. And these two angles are in alternate position. Then you can say that BC is parallel to AD. The same with respect to the second required. If these two angles, BEC and ABE, are equal in measure, then you can say AB is parallel to EC. How to prove that these two triangles are similar? We'll use the given as follow in the solution. We have AB over DA equals CE over BC from the given. Then AB over CE equals DA over BC, and we write it AB over CE equals DA over BC, and this is number 1. Also from the given, BD over DA equals EB over BC, we write it. Then antecedent over antecedent equal consequent over consequent, and we write it BD over EB, we write it in fraction and ratio, equals DA over BC, like this. From this 1 and 2, we have a common term, DA over BC and DA over BC. So these 4 terms are equal, and we write it. Then AB from 1 and 2, AB over CE equals BD over EB equals DA over BC. Okay, and here you look to the figure, back to the figure. AB over CE, AB over CE equals BD over EB, BD over EB equals DA over BC equals DA over BC. Then the two triangles ABD, and we write it on the same arrangement, on the same order. Then triangle ABD is similar to triangle CEB. Triangle ABD similar to triangle CAB. Here, AB over CE, we start with AB and CE. BD and EB, we write it BD and EB. Now, since the two triangles are similar, we have two similar triangles, then the corresponding angles are equal in measure. The measure of angle ADB equal measure of angle CEB. Measure of angle ADB, this angle, equal measure of angle CBE, and they are in alternate position. So you can say AD is parallel to BC, and this is the first required. And also measure of angle ABD equal measure of CEB here, CEB. then these two sides CE and AB are parallel because these two angles are in alternate position with respect to the transversal BE.